Hello friends, in this video I will be discussing graph. So graph is a nonlinear data structure and it is represented by using vertices and edges. So basically data structures are of two types. One is linear and other one is non-linear. So these terminologies are due to the arrangement of data. Either it can be arranged in sequential manner or it can be arranged in non-sequential manner. So if we observe graph, like from a data we can move to more than one data items. So like the datas are arranged in non-sequential manner. So therefore graph is a non-linear data structure and it is represented by using set of vertices and edges. So this is a graph where these are the vertex and this is an edge. Okay, so edge is basically used to connect vertices. So if we see the set of vertices 0, 1, 2, 3, 4 are the set of vertices, and the line which joins the vertex are known as edges. So if we see this set of edges, we find that 0, 1 is a edge, 1, 2 there is a edge, 2, 3 also there is a edge. Okay, so we can represent graph by using vertices and edges. So there are various applications that uses graph. One of the most important applications are social network like Facebook, LinkedIn, Instagram. These are some sort of graphs where the people are the vertices and the connections between the people are edges, like the friendship relations, etc. So graphs are broadly distributed into two. Like we can categorize graphs on the basis of parameters. So the first parameter is the direction. Like it is classified into directed and undirected graph. So if we see the directed graph, we'll find that there is a direction from one vertex to other vertex. If we consider this as a pair, like u is the initial vertex and v is the final vertex, then we will find that there is a direction from u to v. So if we observe this graph, we'll find that 1 to 2 there is a directed edge, 2 to 3 there is a directed edge. So in directed graph there will be ordered pair of vertices. So if we consider this set of edges, we find that 0 comma 1. So in undirected graph, it is not mentioned, like there is no direction. So 0 comma 1 and 1 comma 0 are same in case of undirected graph. But in case of directed graph, it is not same. 0 comma 1 means that there is a edge starting from 0, from vertex 0 to vertex 1. Okay, so graphs are of two types mainly, like directed and undirected. In directed there is an ordered pair of vertices, in undirected there is unordered pair of vertices. Like 0 comma 1 and 1 comma 0 are same in case of undirected. And moreover in directed graph we'll find directed edges. In case of undirected graph the edges are undirected. Okay, so now we'll discuss another term, that is degree. So degree of vertices. So if we see undirected graph, the degree of a vertex is said to be the number of edges to which that vertex is connected. So if we see this vertex 1, this edge and this edge is connected to this vertex 1. So the degree of vertex 1 is 2. Okay. Now if we see this degree, like if we see this vertex 3, the degree of vertex 3 is this and this, that is again 2. Now in case of directed graph, as there are directed edges, so basically the degree is divided into two. One is in degree and the next one is out degree. So as the name suggests, like in degree means the edges which are moving inside of a inside to a vertex. Like if we consider this vertex 2, so in degree is this edge. So how many number of in degree edges are there? So right now only one. So in degree of vertex 2 is 1, and out degree of vertex 2 means the edge which is coming from vertex 2 to some other vertex. So out degree of vertex 2 is also 1. So this is known as a degree. It helps to find like how many vertices are connected to a single vertex. So we can represent graph by using adjacency list or adjacency matrix. Okay. So adjacency list means like we can represent it by using linked list or using vector array. So suppose I'm making a vector array which will be of int type, okay, which will be of int type, and the name is like arr, and this is an array of size number of vertices. So if we observe this graph, we find that there are 4 vertices. Okay, so I'll be creating an array where each cell will contain a vector, and the index number of this cell is used to represent vertex. So this is my vertex. Okay, and we'll have vector in each cell location. Okay, so suppose 0 is connected to 1, so we will place 1. Then 0 is connected to 3 also, so we need to place here 0. Okay, and 1 is connected to 0 and 1 is connected to 2. 1 is connected to 2. So if we see this, this is nothing but the representation. So by this way we can represent the graph, like instead of having element in each cell, we are having vectors, and inside the vectors we are containing those elements to which a vertex is connected. So 0 is connected to 1 and 3, so inside 0 we are keeping 1 and 3 in our vector. Now 1 is connected to 2, 3 and 0, so inside 1 we are having 0, 2 and 3 in a vector. So basically this 0, 1, 2, 3, the index number is used to represent the vertex of a graph, and the vectors which it contains will have those elements to which this vertex is connected. Now adjacency matrix. So in adjacency matrix, it's a simple way to represent a graph. This is the vertices which are available in the graph, like 0, 1, 2, 3. So in row and in column, and in row, this is 0, 1, 2, 3, 0, 1, 2, 3. And if the vertex are connected, then we will have 1, otherwise 0. So if we see 0 and 1 is connected, so 0 row and first column will place 1, which indicates connection. Now 0 and 2 is not connected, so 0, 2 is not connected, so we'll have 0 as a value of the vertex which are not connected. So by this way we can represent, we can further divide the graph into two, that is weighted and unweighted. So weighted graph means to each edge there will be some weights or values associated with it. So if we consider this graph, we find that there is an edge from 1 to 2 and value 10 or weight 10 is associated to this edge. And unweighted graph means like there is no value or weights. Okay, so it's a simple, like it's a simple graph without having any weights and values. So in case of like weighted graph, where we can use weighted graph, there are many more applications. Like if we see the connectivity between cities, so cities are connected and the values or the weight associated to connect a city is basically distance. So this distance can act as a weight. So by this way we can represent this weighted graph in terms of connecting cities or in many other terms. Okay, now there are some more terminology. The first terminology is walk. So walk is sequence of vertices in a graph, okay, where vertex can be repeated, edges can be repeated. So if we consider this graph, like we can move from 1 to 2 to 3, again we can move from 3, we can move to 2 to 1. So this is walk. It's basically a sequence of vertices where we can move from one vertex to other and we can repeat vertices. Okay, so this is walk. Now next is path. So path is a walk, but we can't repeat vertices. Like from 1 we can move to 2, from 2 we can move to 3. So this is known as a path. Okay. Now third is cycle. So what is cycle? Cycle is basically a path. It's a closed path, we can say. Like from 1 we can move to 2, from 2 we can move to 3, 3 to 4, and 4 to 1. It's a closed path. In path, there is no repetition of vertices. In cycle also, we can't repeat vertex, but the starting and the ending vertex must be same. So this is known as a cycle. So again, we can further divide graphs into the graph having cycle, that is known as cyclic graph, and the graph that do not have cycle are known as acyclic graph. So what is an example of acyclic graph? It's nothing but tree data structure. So in tree data structure, there are no cycles, and this make tree different from graph. Okay, so tree is basically acyclic in nature, having no cycles. Yeah, so next is like connected graph. So connected graph means from one vertex we can move to another vertex using a path. Like there must be a path from one vertex to other vertices. So if we consider vertex 4, so from 1 we can move to 4, from 2 also we can move to 4, from 3 also we can move to 4. Like there must be a path from one vertex to other vertices. So this is known as connected graph. And suppose like this is vertex 5. So from 1 we want to move to vertex 5. Okay, suppose this is a graph like 1 2, and 1 2 is connected, and say 3, this is also connected. Okay, next here is vertex 4. So from 1 I want to move to vertex 4. So how I can move? Like there is no path that exists between vertex 1 to 4. So this is known as disconnected graph. Okay, this is an example of disconnected graph. Okay, so this is a basic terminology.